Hi there. In today's lecture, we're going to do a bit more on conic sections. Okay, so we're going to be looking at finding the vertices, the foci, finding the asymptotes of hyperbole, and we're going to look at some sketches of them using the online calculator called Desmos. Okay, so I encourage you to take a look at that website. So just go on desmos.com, look for the calculator, and you can use that for plotting these graphs. Okay, so plot some of them, plot the vertices and the asymptotes and the foci, and change some values to see how that affects those different features of the graphs. Okay, but I'll show you how to use all of that in today's lecture. So the first one that we're going to be looking at is the ellipse. Okay, so we'll do a pretty easy example just to show the machinery of the calculations and what this shape looks like. So we have x squared over 4 plus y squared over 9 is equal to 1. And remember that 4 is actually a squared, so we need to take the square root to see what the value of a is. So a squared is 4, so a is 2. Okay, so remember those values below the x squared and y squared, those are a squared and b squared. So if you want the value of a and b, you need to take the square root. Okay, and then those are always positive. Okay, so if we imagine if we take the negative here, that's going to change the shape. So we take them as positive. Okay, and then b squared is 9, so that means b is 3. Okay, so very important to see what these values are before we continue. Okay, so the first thing that we want to find are the foci of the ellipse. So we did briefly go over that in the previous lecture. So the first thing that we need to calculate is the eccentricity. So E, that is the square root of 1 minus a squared over b squared. So that's going to be the square root of 1 minus 4 over 9, and that will be root 5 over 3. Okay, so that's just simplifying what's under the root there. Okay, so that's the eccentricity, and then to find the foci F, that's going to be the eccentricity multiplied by, in this case, 3, here, because that will be the semi-major axis. So sometimes the semi-major axis will be the A value. If that's bigger, here we take the value of 3 because that one's bigger. Okay, so in this case, a quick little sketch, it will be an ellipse, something like that. So we see the major axis is vertical, and then the semi-major axis, or the semi-major distance, that will be 3. So here's 3, minus 3, 2, and minus 2. Okay, so the foci will lie along that major axis there. That's why we chose B. Okay, so it will be the eccentricity times B, because that's the larger value. So that will be root 5 over 3 times 3. So that is root 5. So we have the two foci. The one focus will be at the top, and the other one will be at the bottom. So the foci, one of them will be at the top, so that will be 0 root 5, and then the other one will be at the bottom, so that will be 0 minus root 5. Okay. There is another way to calculate this. So if we take the eccentricity formula and then just rearrange some things a bit, we can calculate this value c, or actually c squared. This will be b squared minus a squared. Again, we're just simplifying that eccentricity. From here, we get c squared is equal to b squared minus a squared, so that will be 9 minus 4. That will be 5. So then c is root 5, and that is our focus. Okay, the root 5 and the minus root 5. Okay, so this just comes from rearranging this expression here for the eccentricity and then substituting it into this expression with f, and then we can calculate this value c. Now remember that we need to take the square root, so here we took b squared minus a squared so that we got a positive number. If this were swapped around and b was smaller than a, then we would have to take a squared minus b squared. Okay, so we just need to remember that the c squared must be positive, of course, because it's a squared number, so just keep that in mind. Okay, so this may be swapped around if b was less than a. Okay, so that's just another way of finding it. It's exactly the same as using the eccentricity in that first box and then finding f in that second box. Okay, so that's up to you, whichever you prefer. Okay, and then the vertices, so remember they will be this top point here and this bottom point here along the major axis because that's the longer one. So we have 0, 3 and 0, minus 3. So vertices 0, 3, that's the top one. 0, minus 3, that's the bottom one. And then the co-vertices, that's along the smaller one, the smaller axis. So that would be minus 2, 0 and 2, 0. Okay, so then just a note here for this one. Remember, this is the longer axis or major axis. And then the co-vertices, those are on either end of the shorter axis or the minor axis. Okay, so I'm not too worried about the naming that you use. You can call it the major axis, the minor axis, you can say the longer axis or the shorter axis, as long as you understand the difference between the vertices being along the longer one and the co-vertices being along the shorter one. Okay, so I'm not too worried about what you call it. Okay, but if you do look up this information online, just note that they do use major axis and minor axis. Okay, so just keep that in mind. Okay, so that's everything that we need to know with regards to calculating. So we've got the two vertices, the two co-vertices along the major axis and the semi-major axis. That's all we really need to do the sketch. Okay, just connect the dots like that. And then we've also got the two foci, again along the major axis. Okay, so let's see what this looks like in Desmos and see if our little sketch on the right there matches up. Okay, so we've got Desmos over here. So you can click on the side, on the left side here, to type in the equation. So let's put the equation of our ellipse. So that's x squared over 4 plus y squared over 9 is equal to 1. Okay, and then let's just zoom in here so we can see what we've got. So you can just click on the graph and then that will show you any interesting points. So here at the top we've got 0, 3, which is exactly what we calculated for the top vertex. For the bottom vertex here, 0, minus 3, again that's what we got. And then on the left and the right we've got here 2, 0, minus 2, 0, again that's what we calculated. Okay, so let's see where the foci go. Remember we had that value of root 5, and that would be along the y-axis. So we can just put in the point 0, square root 5, that's at the top, and then 0 minus square root 5, that's at the bottom. Okay, so we've got our two foci over there. Okay, and then you can also change the color here. So if you just hold on the point there, we can change the color like that. We can change the shape of what it looks like. So you can put a cross, you can put an open circle, closed circle, and so on. Okay, so I encourage you, please use Desmos to see what these look like, and then you can see where these points are and what the general shape is like. Okay, but don't use it to get the answer right away. Please do the calculation to see how you get the answer, and then you can check using this. Okay, so remember in the test and assessments and so on, you're not allowed to use any online calculators or anything like that. So you should be able to do it by hand. But for the tutorials and homework, please use this. Okay, next let's look at an example with a parabola. So number 2, parabola. Okay, let's just write the two standard forms of the parabola so we can see what we need to work towards. So for a vertical parabola, okay, so in the previous lecture I did go through the two different types. So we have for a y is equal to x squared. Okay, and then for a horizontal parabola, we have for a x is equal to y squared. Okay, so you swap x and y and you go from being vertical to being horizontal. And again, I point out this 4 over here. Okay, so please make sure if you're writing it in the standard form that you've got this 4. If you don't have it in this form, then your value of a will be incorrect. Okay, and your focus value will be incorrect because of that. So please make sure you have that 4 there. Okay, so let's have a look at an example. So we have y is equal to 2x squared plus 4x minus 1. Okay, this isn't in standard form. Okay, so this is just a trinomial, which is quadratic. We want it in this form of either vertical or horizontal. Since we have a value of y just by itself, and we've got a x squared, we know it's going to be vertical, but we can't see immediately what the value of a is. Okay, so we can't find the focus and we can't find the vertex. Okay, so let's do a little bit of manipulation to get it into that form. So the first thing we can do is complete the square on the right-hand side so that we can get x by itself. So we have y is equal to 2, x squared plus 2x minus 1. And then inside the brackets, we can complete the square. So we get 2x plus 1 squared. So if we multiply that out, we're going to get x squared plus 2x plus 1. We don't want that extra 1, so let's subtract it. And then the minus 1 from outside. So here we get y is equal to 2. X plus 1 squared minus 2 minus 1. So that will make a minus 3. So y is equal to 2. X plus 1 squared minus 3. Okay, almost in standard form. Let's take the 3 across. So we get y plus 3 is equal to 2x plus 1 squared. Okay, so we're almost there. Let's take the 2 across. So we're going to have 1/2 y plus 3 is equal to x plus 1 squared. So now it's almost in standard form. So we've got the x by itself, but it's just been shifted by 1. We've got y alone there, but that's been shifted by 3. So we've got a vertical shift on y, a horizontal shift on x, but we don't have the factor 4. We need to include that. So instead of writing 1/2, we can write this as 4 times 1/8. Okay, that will give us a half. And then y plus 3 is x plus 1 squared. So with the factor of 4 in front, we can read off our value a. So that's 1/8. And remember, that is our focus value. Then y plus 3, that means we have a vertical shift by 3. We will plot this in a bit to see if it's a shift up or shift down, but please think about that before we get there. And then x plus 1, that's a horizontal shift. Again, please think about if that's going to be a left or a right shift. Okay, so just make notes. Do you think it's left or right for the horizontal shift? Do you think it's up or down for the vertical shift? Then we will plot this and see what we get. Okay, so let's go back to Desmos and see what we get. So let's clear this. So we will put our original formula. So y equals 2x squared plus 4x minus 1. Okay, so we get this parabola here. And then let's put that other one that we found. So that would be 4 times 1 over 8 y plus 3 is equal to x plus 1 squared. And we see that they overlap perfectly, so we know our answer is correct. Okay, so let's get rid of the first one. We can work with this. Let's look at the shifting. So we see here minus 1 and 3. That's exactly what we expected. So y plus 3, that's going to be a shift down. Remember, it's y minus 3 to get y plus 3, so that's a shift down. And then x minus 1, so that means it's a leftward shift. So the vertex is at minus 1, minus 3. So let's put that down. So since it's y plus 3, we can write that as y minus 3. And then x plus 1, we can write as x minus 1, which means the vertex, or the turning point, will be at minus 1, minus 3. We can just read off these values like so. Okay, so that's the vertex. What about the focus? So the focal length, so that's the distance from the focus to the vertex, is 1 over 8. So here we know that the x part of the focus will be the same as the vertex at minus 1. So minus 1. Then the vertical part of the vertex, that's minus 3. And then the focus is just 1 over 8 units above that. Okay, so then there's the focus over there. Okay, so that is the vertex at the bottom, and then the focus in the middle there. Okay, that green dot. Okay, so that's the parabola, and then you can do almost exactly the same, so same sort of working out for the horizontal parabola. So that means if we swap here, let's go back here, we swap y and x, so we get a new parabola. So here's x and y. We get a horizontal parabola. So now the vertex is at minus 3, 1, because we did that swapping. And then the focus, the x part, again, we swap them around. So that will be minus 3 plus 1 over 8. And then the y part, that's the new y part of minus 1. Okay, so then we get this purple dot over here. That will be the new focus if this was horizontal. Okay, so just keep in mind when you're finding the focus, it's offset from the vertex. If it is a vertical parabola, we just shift it up a bit by the focal length. If it's a horizontal parabola, we shift it across like that. Okay, and if this A was negative, we flip it around. So now instead of pointing to the right, since A is negative, we're pointing to the left, and then we can shift accordingly. Okay, so we can put a minus A there because it's a minus 1 over 8, and now the focus is in the right place. Okay, so I encourage you, please go on Desmos, mess around with some equations, change the values, and see where the vertices go if we do some transformations, and where does the focus go if we do some transformations. Yeah, and then that would obviously be vertical, horizontal shifting, and also changing this A value. So maybe if we write this as minus 1/3, and we can put here minus 1/3. Okay, so that changes some things around. Okay, so please go on Desmos, look at these different graphs, and change the values to see what happens. Okay, and then before you plot the points, just try calculate where it should go, then you can plot the points and check if you're correct. Okay, so that's it for the parabola. The last thing to go through is the hyperbola. So that's number 3. Hyperbola. Okay, so let's look at a pretty simple example. So we'll have x squared over 4 minus y squared over 9 is equal to 1. So very simple, very similar to that ellipse that we had, except the plus changed to a minus. So remember, if we've got a minus between the terms, it's a hyperbola, not an ellipse. Again, very similar to the ellipse, these values below the x squared and below the y squared, the a squared and the b squared, those are squared values. So a squared is 4, so a is 2. B squared is 9, so b is 3. Please do not mix up a squared with a or b squared with b. Okay, so these are the values that we need in our calculations. Okay, so again, please remember that. Okay, let's first find the foci. So we can find it using the eccentricity. So the eccentricity here will be 1 plus a squared over b squared. So that will be the square root of 1 plus 4 over 9. Okay, and that will be root 13 over 3. Okay, and then once we have the eccentricity, we can then find the focus or the focal length, and then that will be root 13. Okay, so please, if you're not familiar with the eccentricity or the focal length, please go back to the previous lecture where we look at those formulae. Okay, so here we can use this to then find the two foci. So since this is a horizontally oriented hyperbola, so if the x squared is first, so x squared minus y squared, then this is going to be horizontal like that. If it was y squared minus x squared, then it would be vertical. Okay, so just keep that in mind when you're doing these. Okay, so then this will be at minus root 13, 0, and, root 13, 0. Okay, so along the x-axis. Okay, so that's using the eccentricity. We can also do it with a little bit of manipulation there. So we can find a value that we call c squared, very similar to what we did with the ellipse, but here it's c squared is equal to a squared plus b squared. Again, a little bit different to the ellipse. So then this will be 13. So c will be root 13, which is the same as what we got previously. Okay, so again, with the ellipse, you can either use the eccentricity to calculate the focal length, or you can use this c squared value. Okay, but then once you have c squared, make sure that you take the root to get c. Okay, so it's about the same amount of work for both. I'll leave it to you to find which one's best for you. Okay, or maybe you find something else online that works better. Please use that. But make sure that you show all your working. If you're going to use something that I haven't seen before, please make sure you show the working so I can see the idea behind it. Okay, so don't just write down the answer. I don't know where you got it from. Okay, and then the vertices. Okay, again, pretty easy to do. Since we know it's a horizontally oriented hyperbola, we look at the a squared value, which is 4. That gives us a is 2. So we know that the vertices will be at minus 2, 0, and 2, 0. Again, along the x-axis. If this was a vertically oriented hyperbola, then these points will be along the y-axis instead. Okay, so please, like I said before, go on Desmos, plot these, look at vertically oriented, look at horizontally oriented, and see where those points end up being. Okay, so that's the vertices. And then the last thing for hyperbole in particular are the asymptotes. Okay, if you're unfamiliar with the asymptotes, please go through the notes that are posted on the Learn page. Okay, but just briefly, if you forget the formula for the asymptotes, you can use this calculation to quickly figure out what they are. Okay, so let's say we have x squared over a squared minus y squared over b squared is equal to 1, and we want to find the asymptotes. Remember, the asymptotes are those two straight lines which the arms of the hyperbola approach at infinity. So as x goes to infinity or minus infinity, those two arms will approach the asymptote lines. Okay, so how do we find it? Quick rearranging to solve for y, we have y squared over b squared is equal to 1 minus, let's just do it a bit slower. So we have x squared over a squared is equal to 1 plus y squared over b squared. Okay, then we can subtract the 1. So we have x squared over a squared minus 1 is y squared over b squared. Then we can factor out an x squared on the left there. So we can have x squared 1 over a squared minus 1 over x squared is equal to y squared over b squared. Okay, and now we do our limit, because remember, like I said, the asymptotes are the limiting behavior of those two arms. So when x is very, very large, 1 over x squared becomes very, very small. So we can just neglect that. So then we have x squared times b squared over a squared is equal to y squared. So y is equal to plus minus b over a x. Okay, and these are the two asymptotes that we get. So we get the one with the positive gradient and the one with the negative gradient. And if the hyperbola were shifted, then this would also shift. So if we want to shift this, we can say y minus k is equal to plus minus b over a x minus h if we were to do a horizontal and vertical shift. Okay, but that's very easy. Once we know the original, shifting x and y is just minusing h on x and then minusing k on y. Okay, so it's very easy to get there if we know what the original was. Okay, so in our case, what is this a and the b? So a is 2, b is 3, so then the asymptotes would be plus minus 3 over 2, because it's b over a. So here we have y is equal to plus minus 3 over 2x. Okay, so let's have a look at Desmos to see what this all looks like. So we go back here, let's get rid of our parabola. So we have x squared over 4 minus y squared over 9 is equal to 1. Okay, so we get our parabola. We see it's horizontally orientated. So we've got the right-hand side there pointing to the right, and then on the left we have that pointing to the left. Okay, if we were to swap this around, which I encourage you to do to see what happens, we would end up with something vertically orientated. Okay, the vertices, we calculated that as minus 2, 0 and 2, 0, and we see that those are the two turning points. So we've got the turning point on the right and the turning point on the left. Okay, so that's what we calculated, so everything's alright with that. The two focus points, the two foci, we had the focal length of root 13. So one of them is going to be at minus square root 13 and 0, again along the x-axis, and then that means the other one is at root 13, 0 along the x-axis. And if this hyperbola was shifted, then the vertices and the foci would shift along with it. So just as an example, so let's say x minus 1. So we shift everything across. We can then just, we can shift everything here. Okay, so then we can put here minus 1. Plus 1 there. And then here, whoops. Okay, and then we can shift that across. Okay, so you see how everything shifted over to the right, and then all these other points also moved across to the right. Okay, and then the asymptotes, what are they going to look like? So let's just clear these points and put this back like we had before. The asymptotes would be at y equals plus 3 over 2x, and we see that that does have the behavior that we were going through. So here, when x goes to infinity, we see this top right part of the arm approach the red asymptote line, and then on the other side, we see that the bottom left part of the arm, that also approaches the red line. Okay, so that's the limiting asymptotic behavior. And then we also have the minus one, so minus 3 over 2x. So that's the blue one here. We see that the bottom right part, that also approaches the blue line, and then the top left part, that also approaches the blue line. Okay, so we have this, these two asymptotes. And then, of course, if we shift this again, so let's shift everything over by 1, then the asymptotes must also be shifted over as well. Okay, so everything's shifted over by 1. So the graph has been shifted because it's x minus 1, and the asymptotes will also be shifted, again, x minus 1. If we shift the y, so let's say y minus 2, okay, that's shifted up there. We can also shift this by 2 to match that. Okay, so that's also shifted up now. So we did a shift to the right and a shift up. We get this new point in the middle there. Okay, and then everything shifts along with it. And then the vertices we see here, if we just click. So we can zoom in here, and then we can see the vertices somewhere along there. There go 3, 2. That's the new shifted vertex. Okay, so please, again, have a look at this, desmos.com. Put in your different conic sections, change some values, and see what happens. So see what happens with the vertices, the foci, and the asymptotes. Another nice feature is we, instead of putting in values like just minus 1, we can put values like, let's say h, add a slider, and then here we can change this to an h, and we can change this to an h, and now we can just change the slider. See, and then that moves it along as well. Okay, and then for the minus 2, we could make that a k, and then this minus 2 we could make a k, and then this one we could make a k, and now we can shift up and down. Okay, so we've got these sliders to move things around, and we can see how the asymptotes move with it. Okay, so please have a look at that. And again, please do not rely on this to do the homework. Please try do it on paper so you get an understanding for what's going on, and then you can play around with this and check your work afterwards. Okay, so for tests and assessments, we can't rely on this. That has to be done on paper. But checking your answers after the tutorials, that's perfectly fine to visualize what you're doing. Okay, so that's it for today. If you have any questions, please email me or make an appointment. So Wednesday, that's a public holiday. But if you do have questions, please please don't hesitate to email me then. And then Thursday, we will have the tutorial assessment. So this week it will be an MCQ, since the previous week was a written test. Okay, and then again, like I said before, it will alternate. So now we have the MCQ, next week it will go back to the tutorial test. And the scope will be on these conic sections. So identifying conic sections, finding the vertices, the foci, and in the case of hyperbole, finding the asymptotes. Okay, so all of that may come up. Okay, but if you have any questions, please just email me or make a booking if you want a one-on-one meeting. Okay, I'll see you next time.